Hi, now we will see why Hadoop is needed and what is the basic architecture followed in a Hadoop and the components of Hadoop such as MapReduce and Yarn. So why Hadoop is needed? As already discussed, Hadoop it is mainly used for data which need higher storage as well as which need a faster processing. So if you see the advantage, first one is it is used when we have a high speed data generation, and it is used to solve the data set storage issues, and it can support the different formats of data. So these are the three different advantages why we need a Hadoop. And then if you see the architecture, the basic architecture, it supports a master slave format. So master slave, it is responsible for assigning the task to various slave nodes. Also it maintains the resources as well as it maintains the metadata information, whereas the slave nodes, it is responsible to perform various actual computations and it store the real data. And it has the three layers in its architecture. The first one is the MapReduce, the second one is Yarn, and third one is HDFS. So if you see in this picture, so we have three layers. The first one at the top layer, we have the application layer, and the main component available in that is a MapReduce, and we have other applications also. Whereas the second layer, we have the resource management layer, which is the main component available here is the Yarn, and the storage layer, we have this HDFS. So MapReduce, so as we saw in this picture, so we are the MapReduce which is available at the application layer level. It distributes the data into small pieces and it assigns these pieces to many machines. Like as we know, it is a master slave. So one common work has been distributed into many sub works, and it is provided to many slaves. So that's what here it is mentioned in the second point. It distributes the data into small pieces and assigns those pieces to many machines, and at the end it is joined over a network and assembles all the events to form the last event data set. And if you see the fundamental unit which is available in your MapReduce is the key value pair. What is a key value pair in the sense? Let me give you an example. Everyone have their own Aadhaar card. So Aadhaar card, we have some number. So whenever this number is provided, so the machine will tell you who is that person and the address and other details also. So here the key means the Aadhaar ID number and value means the information about that particular person. So this MapReduce, it follows the key value pair. And here the important point is it uses the processing unit in the storage level. So it means the processing unit is moved towards the data but not the data moving towards the processing unit. In other frameworks and all, the storage unit will be there and the processing will be happening when the data is moved towards it. Whereas here, whenever the data is present, whenever the input is given, the storage unit will not do any work, whereas the processing happens at the input layer level itself. So it has the two phases, one is map and other one is the reduce. So in the map level, so it uses the data collected from the user and it is converted into a pair of key and the value based on the business logic, that is which we call it as a mapper phase. Whereas the reduce phase, it takes input as the output generated by this previous phase, map phase, and applies the aggregation based on the key value pair. That is, it reduces whatever content produced by the mapper phase, it reduces it, and so that you will have one final output. So here I have an example. So I have three different statements which is given by the user. One is are you good, how are you, and how you good. So whenever these three statements are given to the MapReduce, so these are the different activities performed inside the MapReduce. The first one is the splitting. Splitting, what happens? So here the three statements are given in one at a stretch. So all these are splitted as three different statements. Like are you good? It is giving in one statement. How are you? It the second statement. And how you good? This is the third statement. So this we call it as a key value pair. The next level of work is mapping. So here it is going to provide each and every word with a value. Like here, if you take the first statement, it is are you good? So it means R is provided with the value as 1, U is provided with value 1, and good is provided with the value 1. Why they are providing 1? In the sense, in this statement, R is being given as 1 time, U is given as 1 time, and good is given as 1 time. Suppose in my statement, if I have 2 times of R or 2 times of U or 2 times of good, then the value will be changed as 2, 2, 2 accordingly. So this is like a mapping. So where I'm providing using the list, whereas it uses the key value pair. So each and every word has been assigned with some value. So similarly, the second statement is also provided with certain value, key value pair, and third statement is also made it as a key value pair, and this is called mapping. So till here, this is the mapper phase, whereas here the shuffling, reducing, here we call it as a reducer phase. So in the second level of processing, which we call it as a shuffling, so here the first the values or the the words which are in common with all the three three statements are taken. For example, are you good? So it is given at 3 levels, and whichever statement is having R, that has been combined here. So here, are you good? So I have taken. So R is present in the second statement also. So here 1 comma 1, that is in the first statement I have one value of R, and in the second statement also I have one value of R, that is 1 comma 1. And if you see the second word U, so in all the three statements and I have U, so that's the reason I have 1 comma 1 comma 1, that is all the three statements they are having this word called U. Similarly for good, it is present in first statement and the third statement, so it is 1 comma 1, that is one time it is repeated in the one statement and one time is repeated in the other statement. And how also I have, it is present in two statements, how are you and how you good, so it is 1 comma 1. So now it has to be, so this shuffling has to be reduced, we call it as a reducing. So I have to add all these numbers. So R, it is 2 times repeating in this 3 statement, so R is 2, U is 3, good is 2, and how is 2. So all these are being reduced now. The shuffling part is being reduced, and then the final result we will get it as how many times of words are being repeated. So that is called map reduce format. So mapper phase, it is used to map the input key value pairs into some intermediate one. Then each map is used to transform the input records into an intermediate value. The framework, it follows the grouping of all these intermediate values, and in Java how it is being performed, it is using a comparator class, and especially the library called job.setGrouping comparator class. So this is the one which is being used by the mapper phase in Java programming. Whereas in reducer phase, so it the set of intermediate values which we received it from the map reduce has been used here. So it has 3 phases, primary phases here. The first one is the shuffling, and the second one is the sort, and third one is the reduce. So in shuffling, the Hadoop framework, it takes the applicable partition of the output of all the mappers which we received in the previous phase, and sort, the Hadoop framework performs the grouping of this reducer by using the keys, and then it sorts the work, and it shuffling also it happens here. So it is the one which is going to do the sorting. Then if you see, then it finally reduces. So this is the final stage, so where it uses these different classes like writable, comparable, iteratable, context methods available in the Java. It is used for grouping each grouped inputs, and the output of the reduce task is written on the file using the other class called writable, comparable, and writable. So the next one is the yarn. The next component available in the Hadoop is the yarn, yet another resource negotiator. It is a full form. So it is a resource management level of the Hadoop. It is used to perform job scheduling and the resource management. And here the basic, if you see the basic idea of yarn, it is used to divide the resource management and job scheduling into 2 different processes and perform the operation. So it has two components mainly. One is the resource manager and other one is the node manager. So both the components it is used to process the data computations at the yarn layer. So the resource manager, it presents on the master node, whereas the other one, that is a node manager, present in the slave nodes. So the resource manager, so it runs on the master node, and it makes the resources available for all the slaves. And if you see the responsibility of the node manager, it used to have the containers and resources which can be monitored by this node manager, and it provides the detail to the resource manager. So if you see the picture here, so the resource manager, it is the master, and here I have the nodes which node manager, these are available in many slaves, and each node manager, it has some containers and application masters or the many containers itself. Whereas the resource manager, it has two parts. One is the scheduling and application management. So we will see that here. So it has a resource manager and node manager. In resource manager, it has the resource scheduling part. It runs on the application manager also. So on the whole, the components present in the resource manager are the scheduler and the application manager. In scheduler, it is responsible for allocating the system resources. So it does only the scheduling part alone. It does not do any monitoring or tracking of any jobs, and it does not do any application failure part also. It performs only the scheduling. Whereas the application manager, it has to accept whatever the computations done by the node manager, it will be given to the application manager. So this application manager, in turn, it will reply to the client. So node manager, it runs on the slave machine. So the node manager handles the container. So what is a container? It is the resource capacity of a node manager. So this node manager keeps sending a beacon to the resource manager at every some seconds. So here if you see the workflow available in a yarn, so I have this resource manager with the application manager, and I have this slave called node manager. So whenever a client is sending an instruction, so it will be given to the resource manager. So the resource manager forwards that information to the application manager. So the application manager, after seeing the information, it will start considering the number of containers required, and it will send that informations to the resource manager 3 and 4. And then it also activates the slaves by sending information, the number of containers is required. So once the containers are ready, the client can send the information directly to the node manager. So whenever the informations are ready, it is sent back to the application manager, and which will forward it back to the resource manager and then to the client. So the working application workflow is given here. So with this, I will stop the yarn part. Thank you.